Okay, so far in lecture videos, we've been talking about measurements and units, and now what we want to talk about is what if we want to convert our measurements into different types of units, and we do that using a fancy word called dimensional analysis. But you do this in your everyday life already, to some extent. So let's take an example here. You probably don't do this example, but that's okay. Let's say we have a 12-ounce soda, and we want to know instead, how many grams is that soda? And all we know so far is that if we had 1.00 ounces, that would be the equivalent of 28.35 grams. So we can take this equation here, this unity that shows this equality between ounces and grams, and we can write two different conversion factors. So we could say that there's 1 ounce in every 28.35 grams, or we could write it upside down and say that there are 28.35 grams in 1 ounce. So these are our conversion factors that will allow us to convert between ounces and grams. We just have to decide which one we're going to use. So we always start these problems with the number that we're trying to convert, which in this case is 12 ounces of soda. And the way we're going to convert it is we're going to multiply by our conversion factor such that we change the units. So if you remember back in the lecture video on units, we treat units just like we do mathematical numbers. So if I put ounces on the bottom, when I multiply, those ounces are going to cancel out. So I'm going to write my conversion factor with ounces on the bottom and grams on the top. So see how I wrote my units first? Then I'm going to fill out the numbers. So that means we're going to use this second conversion factor in our multiplication. So 28.35 grams is 1.00 ounces. So when I do this math, the ounces cancel out. That leaves me with units of grams, and the answer to that then is 340.2 grams. But I'm not done yet. I need to figure out how many significant digits I should be writing down. So this is a multiplication division problem. So we know that the number of sig figs in the final answer is determined by the lowest number of sig figs that we used in our multiplication. So in this case, we had 2 sig figs in this number. We had 4 sig figs in the numerator here and 4 sig figs in the denominator. So that means we should have 2 sig figs in our final number. So we're going to round 340.2 grams off to 340 grams. Or you could even write that in scientific notation, 3.4 times 10 to the 2 grams. So both of these numbers have 2 significant digits. So remember, in this first one here, this 0 is not significant because I didn't show a decimal point. So sometimes it takes more than one conversion factor to do it. Let's take a new example. Let's say instead I have 8,675,309 ounces of gold. And I want to know how many grams is that. But let's say I didn't know the direct conversion between ounces and grams like we did in the last example. Let's say instead I know that there is 1 pound, and that's equal to 16 ounces. And I also know that 1 pound is equal to 453.6 grams. So in this example, I'm going to have to use 2 conversion factors. A relationship between ounces and pounds and a relationship between grams and pounds in order to get to the final answer of how many grams are in my ounces of gold. So again, we start the calculation with the number we're trying to convert. So 8,675,309 ounces of gold, and we're going to multiply that First of all, we're going to convert ounces to pounds in this example. So I'm going to put ounces on the bottom and pounds on the top because I want my ounces to cancel out, leaving me with units of pounds. So that conversion, that equality we know was that 1 pound was equal to 16 ounces. And now that leaves me with units of pounds, and I can use my relationship between grams and pounds to do the final conversion. This time I want pounds to cancel out, so I'll put it on the bottom. That's going to mathematically cancel. So now I'll fill in my numbers. We know that 1 pound was the equivalent of 453.6 grams. So if you do that math and check your sig figs, you should get 2.5 times 10 to the 8th grams for that original amount of gold. And in our last example for this video, sometimes you have to use the same conversion factor multiple times. So let's take a look at an example here. Let's say I have 1 gram per centimeter cubed, and I want to know what's that in units of kilograms per meter cubed. So you can see in this example, I'm going to change the units of both the denominator and the numerator. I'm going to use metric prefixes to do that conversion, so I know that 1,000 grams is the relationship to kilograms, and I know that 100 centimeters is the relationship to meters. And these are exact equations. These are the definitions of the metric prefixes. So let's take a look at how we'll do this conversion. We start with the unit that we're trying to convert, which is 1 gram per centimeter cubed. And let's work on converting the numerator first. So we're going to try and convert grams to kilograms. So I'm going to multiply that times my conversion factor. We want grams to go away, so that's going to go on the bottom, and kilograms should stay on the top because that's the unit we're going to want to end up with in our numerator. So we know that there are 1,000 grams in 1 kilogram. So if I do that math, my grams are going to cancel out, and that's going to leave me with 0.001 kilograms per centimeter cubed. So that's great. I've now got my numerator unit converted, and now it's time to work on converting the denominator. So for the denominator, we're going from centimeters cubed to meters cubed, and I know that I want to be left with meters in the bottom, so this time I've got to get my centimeters in the denominator to cancel out. So I know the equality between centimeters and meters from my metric prefixes. It's 100 centimeters in 1 meter. So if I do this math, my exponents here don't cancel out. I've got a 1 and a 3. So when I do this math, I'm going to get 0.1 kilograms per centimeter squared times meters. So I got rid of one of the centimeters in the denominator, and I added my meter unit into the denominator, but I've got to get rest of these centimeters squared. So instead, what that means is I've got that conversion 3 times. So let's backtrack to where we were after we converted to kilograms per centimeter cubed. So we had 0.001 kilograms per centimeter cubed, and I'm going to do the conversion 3 times now. 100 centimeters per meter times 100 centimeters per meter. I have to go to the next line here. Times 100 centimeters per meter. If I do that math, I get 1 times 10 to the 3rd kilograms per meter cubed, because here I've got centimeters, centimeters, centimeters. That's the equivalent of centimeters cubed in the numerator, which cancels out with this centimeters cubed. And then I've got a meter times a meter times a meter, which gives me meters cubed. So I had to do that particular calculation 3 times in order to get those units to work out correctly. So the important thing to remember, you could also write that as 0.001 kilograms per centimeter cubed times 100 centimeters per meter, that's our conversion factor, cubed. So that says do this multiplication 3 times. But what's important to remember is you have to cube everything. You have to have 100 cubed, then you have centimeters cubed, and then you have meters cubed. So you don't want to forget to cube the number as well as the units. So in order to get good at these dimensional analysis problems, you got to keep track of your units and always write them down, and you've got to work lots of problems to get used to the process.